Welcome to Chapter 6, Filtering Your Data. This is where we truly get into changing data into information. In the last chapter, we looked at some simple calculations, but we were still operating on every row in the record set. In Chapter 6, we learned how to exclude rows from the record set. So let's start. Our objectives for this chapter. You're going to learn how to use the where clause. You'll be able to demonstrate the 5 basic predicates: comparison, between, in, like, and is null. You'll learn how to use the not operator to exclude rows from a record set. You'll use and or, and combined and or in a where clause. You'll be able to explain the order of precedence and how parentheses can override the default order. You'll explore how the null condition impacts the result set. The where clause is used to filter data in a statement that draws from a table. It contains a search condition that it uses as a filter. So this search condition is a mechanism needed to select only the rows or exclude only the rows that are not needed. So it applies the search condition to each row in the logical table that is defined by the from clause. 5 basic predicates that we'll look at are comparison, where we can compare one value expression to another; between, where we can test a range of values between certain values. And remember, as we go through here, that between is inclusive. It includes the first and the last value. The in predicate, which is test for membership; like, which is a pattern match, and if you've used Access, you might call it a wildcard; and the is null. To use the where clause, first look at your original request. Then study the phrase and try to determine which field is being tested, what value the field is going to be tested against, and how the column is going to be tested. Now, you need to know these things in order to help formulate your search condition. Where people tend to go wrong is they're asked to do something like return all the customers that live in the state of Washington. And instead of putting the condition Washington in the state field, they'll put it against the customer field because they're thinking, I want customers that live in the state of Washington. But you need to understand your data. Where does Washington live in your table? It lives in the state column. That is the field that we have to test. So there's an example here. Select the customer name from the customer's table where the customer state is equal to Washington. Now, customer state needs to be in the table or tables, and we'll be dealing with tables when we get into creating joins. It needs to be in the table or tables in order to use it in the where clause, but we don't have to include it in the fields that we're selecting or showing in our result set. Defining our search condition. Of the 5 predicates, the most common is the comparison predicate. It includes equal to, not equal to, less than, greater than, less than or equal to, and greater than or equal to. If the terms less than, equal to, or greater than equal to are not real common to you, I suggest that as you're using them, you actually say them. So that you'll say, I want to know all the prices that are less than or equal to $1,000. And that'll remind you how to write it. Less than, equal to. Comparing strings. Now, numeric and date-time data are usually easily compared. When you're comparing character strings, you need to pay attention to how your database works. Some of your database are going to be case sensitive. So like we see in this example, Mike and Mike are going to have different results depending on the database. Now, you can read the documentation for your database, or like here in SQL Server, as we're playing with some of our queries, go in and write your search criteria in different ways. If we're asked to find all the customers that live in the city of Bellevue, try writing in Bellevue all lowercase, Bellevue all uppercase, and Bellevue in title case. And look at it and see what happens every time you write it. If the results are all the same, then your database is case insensitive. Here's an example of case sensitivity. You can see that in a case sensitive, the numbers come before the letters, and this is pretty standard. But then capital letters come before lowercase letters. In case insensitive, we have the numbers first, and then we have the letters in alphabetical order, regardless of whether or not they start with a capital letter. Also, we have some issues with how the databases adds default pad characters. Now, most of them will drop it so that there's no difference between John without a space in back of it and John with a space in back of it. But be aware of that. Equality and inequality. An inclusive comparison is going to return all of the records only if the current value of the field matches specified criteria. Inequality means that that row is going to be excluded if it does not match the specified criteria. So these are things we're going to be dealing with: the equal, not equal, not. Here's an example. We have show me all of the vendors, and I want vendor name, vendor phone, where the vendor city is not equal to Bellevue. Less than, greater than. I've already given you a couple tips on that one. And note the dates, the way that the dates are set up, and we're going to see this when we're working in our database, that they're year and then month and then day. Ranges, we're going to be working with the between and. And again, this is one of those that if you're not real familiar with working with between and, say it as you write it. I want to know all of the employees who were hired between January 1st, 2012 and December 31st, 2012. Between and is inclusive. So when I write it, I'm going to get people that were hired on January 1st and people who were hired on December 31st. Now be careful with this, because sometimes the time is captured too when you're not seeing it, and you know that people were hired on January 1st but they're not showing. You may need to work with the date so that you're putting in midnight or 12:01 in the morning and 11:59 in the evening to make sure that you're being inclusive of the time as well. What we need to be aware of with the between is we may think that if we want the letter B, we should say between A and C. Remember what I said, that between is inclusive. If I want all of the B's, I need to write my search string or my criteria so that I'm including only the B's. Set membership, we use set membership to test if a value of an expression is within a list of explicitly defined values. We use the in predicate to do that. Here's an example. We want to know all of the stage name of all the entertainers who live in Seattle, Redmond, or Bothell. I could write this Seattle or Redmond or Bothell. What happens there is that you start forgetting the ors as you get about 5 or 6 deep. And so an easier way to write it is in Seattle, comma, Redmond, comma, Bothell, comma, if Woodinville, whatever. So the in is going to test your value against everything that's contained within that set. Pattern match is a wildcard. And in SQL Server, we will be using the percentage and the underscore. If you're working in an application like Access, it takes the asterisk. Here's some examples. These are right out of your book, and so if you're not familiar with using the wildcard, I suggest that you refer to this material in your book or use these slides. I've posted a copy for you at your class site, and refer to those as you're writing your queries. The escape option, it's not really the escape key, but what the escape option does for us is it allows us to write a criteria that includes one of the wildcards. So if we have a product code that begins with G underscore, we have to tell the system that that underscore is a literal. And so that we put a slash in front of it that says the character that follows me is a literal, and then at the end we tell it with the escape and the slash that it is a literal. Null, remember that null is not 0. Null is the absence of a value. And if we're looking for nulls, we don't write not equal to null or is not equal to null. We use the is null and not is null. So using not, sometimes it's much easier to tell the database what you don't want rather than it is to tell it what you do want. For example, if you want a list of all of the cities where your entertainers live, except Seattle, it's much easier to say not Seattle than it is to say Auburn, Tacoma, Renton, Kent, keep going on and on and on. It's easier to say sometimes that you don't want something other than to tell it what you do want. Here's an example. I want everything that was where the order date is not between these two values. Using multiple conditions and or. When we're using the AND operator, all conditions combined must be met in order for the row to be included in a result set. This can be a concept that is sometimes difficult to understand because we may think that if we want all of our entertainers that live in the cities of Bellevue and Renton, we would write Bellevue and Renton. Think about it. Bellevue and Renton do not exist in the same cell. They exist in different records in the same field. So what we really want is Bellevue or Renton. And if the values cannot live in the same cell, then we would get an empty record set. It wouldn't work because using the AND operator, all conditions must be met in order for the results to be returned. So if it's true, true, we get a true, everything else is false. Using OR, either condition can be met in order for a row to be included in the record set. To go back to the example I said about Bellevue and Renton, I want all of my entertainers who live in Bellevue and Renton. So I want all of them really that live in Bellevue or Renton. And so we have to think about it in a different way because those two cities do not exist in the same intersection, the same field and row. So to broaden it, it's Bellevue or Renton. Either condition can be met and the record is returned in the record set. We can combine both and or in our search criteria. And what we need to be careful here is how do we want it to be set up? Do we want it to look for this group first and then look at this group? We need to think about efficiencies when we write it. That's explained in our book. We want to write the search first to get the smallest number of records and then perform our second search against that. We can use parentheses to determine the order of precedence. The NOT operator. The NOT operator is great and you need to know how to use it. Not is null or not in, and then we set membership. If we do not in and then Bellevue, Renton, Auburn, Seattle, we're able to eliminate records by using one not. Otherwise, we would have to write not Bellevue, not Renton, not Woodinville, not Auburn. So combining the in and the not. Be cautious with the not. Make sure you don't use double negatives. Making the select statements better, we talked about this a little bit. Prioritize your conditions to increase the accuracy. And since the search strings are evaluated from left to right, try to write your search criteria so that your searches are the most efficient, that you reduce the records the largest amount on the first search and then search within the record set for the next set of records. There's just some examples here where we're looking for an order date where the ship date equal the order date and the customer ID equal 1001. Well, there could be thousands of records, thousands of where the ship date is equal to the order date, but there may only be one or a couple hundred where the customer ID is equal to 1001. So we look for the customer first, return that record set, and then search that record set for those records where the ship date is equal to the order date. Checking for overlapping ranges. What this really comes down to is it's not just about overlapping ranges. It's about evaluating your output. Look at your result set and try to determine if what you get is what you expect. Now, one way that you can do this is always, with our small database, as you're getting used to it, Run a select all from the table. Look at the data. What I like to do is do a select all, and then I'll do an order by, and I'll choose different fields to order by. And so I'll look at the data and I'll order by date. I'll look at the data and I'll order by customer name. And what this does is just gives me a feel for the data. And so I have an idea of what I should expect when I write my query. When I write my query and I get results that I don't expect, then I know that there's something wrong with my query or there's something wrong with my expectations, and I have to figure out which it is. So as we're going through here, write queries to understand your data, then write the queries to answer the questions, look at the results, and ask yourself, do these results make sense? Do they really answer the question that I've asked? And enjoy queries. Queries are so much fun.